Hello, welcome to my channel, Dr. V.R.K. Reddy. Today, I'll be discussing matrix theory that I have introduced in my previous lecture. Today, I will be covering product of matrices, of course 3 by 3, determinant, adjoint of a matrix and inverse of a matrix. Now, let me take you to the product of matrices. Product of matrices. Note that A and B, that is multiplication of two matrices A and B is possible whenever the columns of A and rows of B are same. That is, A is some m by n matrix and B is some n by n matrix. Then, since this m and n, these are the columns of A and rows of B are matching, therefore AB is possible. The AB is of a matrix n by n, that is, the output is very important. You have to see that the extreme cases, both the extremes, one is this is and then this one, the outermost numbers. So, this is the outer one, we call it rows, and this is outer one and called columns. Therefore, this is how we are calculating the matrix product. If you try to see the other product, that is AB, BA, is it possible to calculate? Is it BA is possible? Product of BA is possible. Answer is what? So, B is n by n matrix, A is m by n matrix. You see here, innermost ones are these two. Not same. Therefore, answer is no. BA is not possible. We have seen yesterday all these things. Let me take, suppose A is equal to 1, 2, 3, 0, 1, 4, 2, 1, 0 and B is equal to 2, 1, 0, 3, 2, 1, 1, 0, 2. Now, I am calculating AB. Here, AB and BA both are possible. That is, here these 3 by 3 and 3 by 3 matrices. So, if you take AB, the innermost ones are these. If you take AB, if you take BA, the other one also same. Therefore, it is possible. What is AB? So, to calculate AB, so you are writing 1, 2, 3, 0, 1, 4, 2, 1, 0 is multiplied with 2, 1, 0, 3, 2, 1, 1, 0, 2. Now, you try to multiply this row with this column. Okay, first element with first element, second element with second element, and move on. This with this and this with this with this, and then the other one is this with this. So, if you multiply, you are getting 1 into 2 plus 2 into 3 plus 3 into 1. Once that complete column is exhausted, you have to move to the second column. That is, you should look at that second column. You have to proceed until you are done with all possible columns, all columns in the given matrix. So that is, I have to do the same procedure. How do I do that? The procedure is that this part must be multiplied with this one, and then this part must be multiplied with second, and then this one 1 3 must be multiplied with 3 2. Therefore, if you write it, you will be getting something like 1 into 1 plus 2 into 2 plus 3 into 0, and then extend this to the further number also, that is this one, that is 1 into 0 plus 2 into 1 plus 3 into 2. That completes the complete row. So, row you have established, out of 3 rows you are going to get, it is a output is a 3 by 3 matrix. Out of that, 1 row you have done. You have to calculate similarly the second row, that is 0 into 2 plus 1 into 3 plus 4 into 1. You look at this, all these numbers, I mean one below the other, always matching. So, for example, what I mean is that 2 2 3 3 3 1 1, it must be same in all those. And similarly 0 into 1 plus 1 into 2 plus 4 into 0, and the other one is that 0 into 0 1 into 1 plus 4 into 2. Again you can notice the same thing, you can see here 1 below 1, 2 below 2, 3 0 below 0, 0 below 0, 1 below 1, and then 2 below. Just so this is how the pattern moves on. And next one, I am taking you to the last one, that is 2 times 2 plus 1 time 3 plus 0 time 1, and the other one is that 2 times 1 plus 1 time 2 plus 0 times 0, 2 times 0, 1 time 1 plus 0 times 2. If you simplify, you will be getting 11, and then the other one is 1 plus 4 5, the last one is 3 2 is 6 8, and then this is 3 plus 4 7, and the other one is 2, the other one is 9. So, next one is 4 5 4 3 7, and the next one is 2 2 4, next one is only 1. This is your AB matrix. This is your AB matrix. You can observe again, you see here all these are falling one below the other, all this column actually were okay. This is how you are doing the multiplication of two matrices. Take one more example, that is A into B. Suppose verify the products AB and BA edges. If edges, calculate AB and BA. A is and 3 2 1 7 8 9, 2 rows 3 columns. B is equal to 1 2 3 4 5 7 8 9 10. So 3 rows 3 columns. This is 1 2 3, 3 columns, C1 C2 C3. So if you look at this, this is 3 by 3, and AB if you want to take, this is something like 2 by 3, this is something like 3 by 3, and therefore these two will absorb, since they are same, there is an outcome of 2 by 3 matrix, there is an outcome of 2 by 3 matrix. Therefore AB edges, therefore AB edges. Next BA, you see BA is 3 by 3 matrix and A is 2 by 3 matrix. And look at that, the innermost entries. The innermost entries are this one and this one, not same. These are not same. Not same. Therefore, BA, that is product, is not possible in this case, not possible. So, hence AB is possible. We are calculating AB. AB 3, 2, 1, 7. So, you should get, we have already seen the 2 by 3 matrix as an output. So, to calculate that, you have to proceed rows with columns until all columns exhaust. Therefore, I am taking 3 times 1, that is 3 with 1, 2 with 4, 1 with 8. This is how you have to complete all elements. So, plus 2 into 4 plus 1 into 8. Once that is done, you are moving to second column, that is 3 into 2 plus 2 into 5 plus 1 into 9. Since all the column elements are exhaust, all these elements are exhaust, I am moving to the next one, that is 3 into 3 plus 2 into 7 plus 1 into 10. So, with that I am exhausted with all columns, therefore, I have to move to second row, that is this is my second row. So, once I move to second row, I have to repeat whatever I have done with this, with the previous row. So, 7 into 1 plus 8 into 4 plus 9 into 8 and 7 into 2 plus 8 into 5 plus 9 into 9. And since second column also done, I am moving to third column, 7 into 3 plus 8 into 7 plus 9 into 10, 9 into 10. This is my matrix and I have to simplify further. This is equal to 8, 8, 16. This is equal to, so this is the result of that AB. Now, I will be taking you to the determinant concept. Whenever you have 2 by 2 matrix, that is abstract matrix ABCD, where ABCD can be any number, any real number. We are focusing mainly on real numbers here. So, determinant of A is represented by the vertical lines equal to ABCD. See, remember these braces must be always vertical. So, that stands for the determinant, the product A into D, and whenever you are moving upward direction minus CB. Remember this procedure you follow everywhere. Whenever matrix is a bigger matrix, we are using the same concept, but with a little slight variation. We will see how to handle that a 3 by 3 matrix. Suppose A is equal to A, B, C, D, E, F, G, H, I. This is the matrix. Now, you are finding determinant of A is what is the question. So, determinant of A is nothing but A, B, C, D, E, F, G, H, I. Remember earlier only 2 rows and 2 columns were there. You are able to solve this problem in a much simpler way. So, instead of that, now you have 3 by 3 matrix. So, this 3 by 3 actually determinant of A is equal to, so you have to follow some submatrix concept. That is, if you focus at this point, ignore the rows and columns. So, you are left with a submatrix, that is this submatrix. This is important. Therefore, A times E, F, H, I, 2 by 2 matrix. This is common even if you have 4 by 4 matrix. If you have 4 by 4 matrix, you are choosing the first element and ignoring that particular row and particular column, you are taking a 3 by 3 matrix. Again 3 by 3 matrix you are writing in the same way, therefore you are getting a 2 by 2 matrix. Once you reach 2 by 2 matrix, product is we have already dealt with. Now I am not keeping any sign between B, I'll come back to that point. Now I have to look at this same row, but this column also I should drop. So if that is the case, I should only consider the this matrix, DGFI matrix. So that is DGFI. I have ignored all those rows and columns that is lying in the first row and first column of B. I'm sorry. I am ignoring the elements in the B column and B row here and collecting the rest of the elements and then placing in the matrix form, determinant form. Last one is C. Again, I am not writing any sign between these things. I will come back to that one. So the leftover element, so that is leftover or something like, okay, now the leftover elements. Now the leftover elements, when you focus at C, you have to ignore that particular row and then particular column, that is D, E, G, H. And now you need to simplify. But before you simplify that, you have to look at, this is called actually cofactoring. We will see that. In adjoint we will use continuously. Of course, it is not exactly that one. There is a difference. We will see that. There is a small difference in it. We will understand what is that. Now, if you look at A is in first row, first column. So, according to the permutation matrix, it is -1 whole power 1 plus 1. The location of row position, column position. First row, first column. Therefore, you will be getting -1 whole power 1 plus 1. What is that -1 whole power 1 plus 1? It is 1. It is 1 minus 1 power 2, that is 1. Therefore, I am keeping plus sign here. And now, I am looking at B. The B location is -1 whole power first row. So, therefore, 1 first row 1 C2. So, my 1 plus 2, that is -1 whole power 3 is -1. Therefore, I am writing minus sign here. Similarly, if you go to C location, C is something like first row, third column. C is in the first row, third column. Therefore, -1 whole power 1 plus 3, third column, first row. So, first row, third column. So, that is actually -1 whole power 4 is equal to 1. Therefore, this is plus 1. So, I no need to write plus 1 or -1. By default, it is. So, sign is enough. So, I am able to write this sign. Again, I have to simplify. That is A times. So, we have seen that whenever you are moving downward, it is positive. Whenever you are moving upward, it is negative, minus HF minus B times. Similarly, DI minus GF plus C into DH minus EG. So, this is the determinant of the matrix A, B, C, D, E, F, G, that is a EFI, that is a general matrix. So, A, B, C, D, E, F, G, H, I is the matrix A and determinant is this. It is a generalized matrix. Now, example. Now, I am taking example, that is A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. you are finding determinant. Determinant of A is equal to, so we are writing vertical braces, that is the standard notation for the determinant. Now you try to simplify it. According to that, you are focused on this, therefore you have to ignore this row and then this column. Then I will be getting 1 time the submatrix 5, 6, 8, 9 determinant. And now I am moving to the 2 here. If I move to 2, the position of 2 is second column first row, that is minus 1 whole power 1 plus 2 is minus 1 whole power 3 is minus 1. Therefore, minus 1 into 2 into the leftover entries. What are the leftover entries in it after leaving the first row and then second column? You are left with this. This determinant you have to find 4, 6, 7, 9. Similarly, the other one plus, because 3 is in third row, 3 is in third row, 3 is in the okay, moving back to this, 3 is in the first row, third column, therefore 1 plus 3 which is equal to 4 which is equal to 1, therefore plus 3 times the respectively submatrix. If you look at that, corresponding submatrix is this one, that is 4, 5, 7, 8. Now I have to simplify. 45 1 time, 45 minus 48 minus 2 time, 36 minus 42 plus 3 times 32 minus 35 which is equal to minus 3. This is plus 12 and this is minus 9 which is 0, is a singular, A is a singular matrix. That means no inverse exists in this case. So this is how we are actually finding determinant of a given matrix. Now I am taking you to the adjoint of a matrix. So adjoint of 2 by 2 matrix I will be taking. For example, adjoint of, topic name, this is, here we are finding adjoint of a matrix. How do you see? If you start with a 2 by 2 matrix, there is nothing. So what you are going to do? Firstly, cofactor of each element. Find cofactor of each element. Write a cofactor matrix. And then apply transpose to it. Take transpose of a cofactor matrix. So cofactor matrix, you are applying the transpose to that one. This completes the adjoint of a matrix A. For example, if you take if you take a 2 by 2 matrix, A is equal to 1, 2, 3, 4. So its cofactors for each element you have to find it first. So cofactor of 1 is, you have to calculate what is the cofactor of 1, which is equal to minus 1. 1 is in the position of first row, first column. Like in the determinant, we have to first row, first column, that means you have to drop this. When you drop this, you will be getting 4. Therefore, the cofactor matrix first row first position, it is giving this one. Cofactor of second 2 is, cofactor of 2 is, cofactor of 1 is that, cofactor of 1 is this, cofactor of 2 is equal to -1 whole power. So, what is 2's position? 2 is in the first row second column, and the moment when you want to apply this, you should ignore the particular row and then column. Therefore, leftover element is 3. Therefore, 3 is the C12, first row second column. Cofactor of 3 is, you should ignore 3. You should ignore 3. I mean this one, you should ignore this column, this row, and you are left with 2, that is -1, that is -1 whole power second row first column, and leftover element is 2. Therefore, this is -1 into 2. Similarly, cofactor of this is actually C21. Cofactor matrix C21 is only position stands for. Cofactor of last element 4 is. So, cofactor of 4 is important. What is cofactor of 4? So, to calculate that, you should ignore this row, you should ignore this row, you should ignore this column. Therefore, 1 is the leftover element, we call it -1. 4 position is second row plus second column into 1, that is anyway -1 whole power 4 into 1 is 1. Now, you are going to have all these positions. This is C22. Now, you substitute all these cofactor matrix. What is cofactor matrix? Cofactor matrix, it is a 2 by 2 matrix, C11, C12, C13, C23, C24, you have to write it. So, cofactor matrix is C11, C12, C23, C24, that is equal to, what is C11? This is -1 whole power, 1 plus 1 is 1 into 4 is 4, therefore, this is 4, and then C12 is equal to, this is -1 into 3, therefore, -3, and C21 position is again -2, and C22 position is 1. Now, adjoint is, you have to apply transpose. Adjoint matrix is, adjoint matrix is transpose of a cofactor matrix. That is, adjoint of A is equal to, so 4 minus 3, I'm sorry, I kept the other, 4 minus 3 minus 2, 1, this matrix transpose, which is equal to, so whenever you are applying transpose, you should flip the columns into rows and rows into columns. That is, this is becoming a column matrix, that is 4 minus 3, and this is actually becoming a row matrix, -2, 1. This is your cofactor matrix, and then adjoint transpose of that. So, adjoint is 4 minus 2 minus 3, 1. Now, I will take you to the adjoint of a 3 by 3 matrix, 3 by 3 matrix. So, how do you find adjoint of a 3 by 3 matrix? Let's take A is equal to, let A is equal to 1, 1, 1 and 1, 2 minus 3, 2 minus 1, 3. This is my A matrix. Now, I have to find if A is equal to this one, if A is equal to this, find adjoint of A, 3 by 3 matrix. So this is very simple. So first we have to find cofactor for each element that gives us cofactor matrix. Apply transpose to the cofactor matrix to get adjoint of A. This is the procedure. So to find cofactor matrix, earlier you have only 1 by 1 matrix, it is easy. Now you have to find 9 such positions. So moving back to first position. So cofactor of 1, that is the first element, first row, first column. So whenever you are finding first row, first column, you should focus on this by ignoring the first row and then first column, that is the submatrix, that is minus 1 whole power 1 plus 1, because this 1 is in the first row, first column, therefore minus 1 whole power 1 into the submatrix 2 minus 3 minus 1 3. This is giving minus 1 whole square. So the determinant is we have already calculated, that is 3 into 2 is 6 minus, whenever you are taking the upward direction, minus sign is common, minus into minus 1 into minus 3. So that is actually giving minus 1 whole square times 6 minus 1 and minus 1 and minus 3. Minus 1 and minus 3 is plus 3, which is equal to 1 into 3 is 3. That is the cofactor of 1 by, the 1. So similarly, you have to find cofactor for each element. So cofactor for each element we have to find it. So that is cofactor of second position. What is that? Second is this one. So if you want to find this one, you have to ignore this row and then this column. So that is minus cofactor of 1 is minus 1 whole power first row second column multiplied with 1 minus 3 2 3. So we have seen that minus 1 whole power 3, and then this matrix you are moving downward, therefore it is plus. This matrix you are taking moving upward, therefore determinant is minus of 2 into minus 3. That is giving minus 1 whole cube times 3 minus into minus is plus, therefore 6 minus 1 into 9 is minus 9. That is your C12 position. Similarly, cofactor of what is that? One more 1 is there. Of 1 is minus 1 whole power 1 plus 1 plus first row third column. If you look at this, this is third row. This is in the first row third column. This is in the first row and third column. Therefore, you can say minus 1 whole power 3 into what is that matrix? The leftover entries matrix is 1 to 2 minus 1. 1 to 2 minus 1. That is minus 1 whole power 4 into. So what is this value? This value is minus 1. Whenever you are taking it is 1 into minus 1 is minus. Whenever you are moving upward, you have to apply 1 minus 2 into 2. So therefore minus 1 whole power 4 is plus 1. Plus 1 is multiplied with minus 1 minus 4. So therefore it is minus 5. Now you are done with the first row only. First row only. You have to move to second row. You have to move to second row. What is that cofactor matrix of? Matrix of, what is the second row? Second row is 1. 1 is minus 1. Second row first column multiplied with second row first column. If you look at this second row first column, second row first column, that is this row first column. So you are left with this 1 1 and minus 1 3 as a submatrix. Therefore 1 1 minus 1 3 is a submatrix. Again same procedure, whenever you are taking the moving downward direction, that is minus 1 whole power 3, this value is 3. Whenever you are moving upward, it is minus already is occupying minus 1 into 1, which is equal to minus 1 whole power 3 is 3 minus of 1 into minus 1, that is equal to minus 1 into 3 plus 1 is equal to minus 4. Minus 4 is the cofactor matrix of C to 1 position, second row first column. Similarly, if you find the other cofactor matrices, that is for 2 cofactor matrix is minus 1 whole power second row second column, and then must be multiplied with 1 1 2 3, that is 1 into 3 minus 2 is 1, which is 1. So next for second row third column minus 3 cofactor matrix is minus 1 whole power second row third column must be multiplied with 1 1 2 minus 1 1 1 2 minus 1, which is equal to this is equal to minus 1 over 5 into minus 1 minus 2. This is minus 1 into minus 3, which is equal to 3, So you are doing repeatedly for every element, then you are getting the for other elements, that is your cofactor matrix is equal to your cofactor matrix is 3 minus 9 minus 5 minus 4 1 3 minus 5 4 1. This is your cofactor matrix. Now adjoint of A is equal to transpose of a cofactor matrix. Transpose of a cofactor matrix, that is 3 minus 9 minus 5 minus 4 1 3 minus 5 4 1 whole transpose, which is equal to, you are actually transposing, this is a row, you are writing in the columns 3 minus 9 minus 5, and this is the second row, you are writing in the columns minus 4 1 3, and the third row you are writing in the column, that is minus 4 5 4 1. This is your adjoint matrix. This is your adjoint matrix of A. So if you are done with that, the last concept is inverse of a matrix. The last concept is inverse of a matrix. Inverse of a matrix. So inverse of A, if A is a given square matrix, of course adjoint and all those things are valid for square matrices, is a square matrix, and determinant of A is which is not equal to 0, then we can find A inverse. What is A inverse? If you can find A inverse, what is that A inverse? So A inverse is equal to 1 by determinant of A into adjoint of A. A inverse is equal to 1 by determinant of A, which is equal to 1 by determinant of A and adjoint of A. For example, we have calculated adjoint matrix in the previous case. Let me take same A. Let A is equal to 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. This is your A. So what is determinant of A? Determinant of A is equal to 1, 1, 1, 1, 2, minus 3, 2, minus 1, 3. So this is equal to 1 into 2 minus 3 minus 1 3 minus 1 into, of course ignoring this row and this column, you will be having 1 minus 3 2 3 2 3, and you are focusing on the first row, third column. Therefore, if you drop this also, you are left with 1 into plus 1 into 1 2 2 minus 1. Look at this, it is 6. So whenever you are moving 6, minus of minus 1 minus 3 multiplied with 1, plus of minus 1 is multiplied with 3 minus of 2 into minus 3, plus 1 into minus 1 minus 2 into 2, which is equal to 1 into, this is minus into minus is plus, therefore already minus sign is there, therefore 6 minus 3 minus 1 into 3 plus 6, this into this is becoming plus 1 into minus 1 minus 4. So this is 3 minus 9 minus 5, which is equal to minus 11, which is non-zero. Therefore, your inverse, inverse of A is equal to 1 by determinant of A into adjoint of A. What is that? It is minus 1 by 11 into adjoint matrix you have already written in the previously. So that is 3 minus 4 minus 5 minus 9 1 4 minus 5 3 1. This is your inverse of A. This is how we are finding inverse of a given matrix. If you don't follow, it's better to look at or start with a simple example that is find inverse of A. 1 2 2 4. So I have started the previous case because I was having cofactor matrix, therefore adjoint information, adjoint of A, and I only need to calculate determinant. I have calculated, I have shown, I have demonstrated how to find the inverse of a matrix. Now if you have any doubt, again this is the, if this is the given matrix, find inverse of A. So first cofactor matrix of A, C11, C12, C21, C22. So what are these entries? So that is equal to, so the moment when you ignore this and this, you are left with 4. Therefore it is 4. Of course, that 4 is multiplied with 1 plus 1, the position. Similarly, -1 first row, second column, whenever you are looking at this 2, whenever you are looking at cofactor matrix of 2, you have to drop this. Therefore, that is 2 here. And similarly, if you look at the second row, if you are looking at this one, you have to drop this row, this column, and then this row, that is -1 whole power second row first column multiplied with leftover element 2, Similarly, if you look at 4, that is the last one. If you look at 4, that is cofactor matrix for 4. Cofactor matrix for 4. Yeah, similarly, if you look at cofactor matrix of 4, so that is this location, you have to drop this row and then this column. Therefore, it is -1 whole power second row, second column multiplied with the leftover elements. If there are more elements, then you have to go by determinant of the rest of the elements. It is a continuous process. So, therefore, -1 whole square is 4, -1 whole cube is -1 into 2, and then -1 whole power 2 plus 1 is -1 into 2, and then -1 whole square whole power 4 is plus 1, that is 1. Now, this is your matrix. Now, this is cofactor matrix. Adjoint of A is equal to transpose of cofactor matrix A, that is 4 minus 2 minus 2 1, you are applying transpose. If you apply transpose, this output is, you have to write this as columns. Therefore, 4 minus 2, these things you have to write as columns, -2 1. This is your matrix adjoint of A. Therefore, A inverse is equal to 1 by determinant of A into adjoint of A. But what is determinant of A? Determinant of A is 1, 2, 2, 3, that is 3 minus 4 is -1, that is -1, which is equal to -1 times 4 minus 2 minus 2 1, that is equal to 4 2 2 minus 1. This is my matrix. Because we have taken this minus sign inside, you have to apply it to the every element. Therefore, that is giving -4 plus 2 minus 1, that is the particular row, and therefore easily this is the inverse of A, inverse of A. I hope it is clear to you. One more example, find the inverse of A is equal to 2 2 minus 3 2 3 2 minus 3 2. We will find how to find the inverse of A. So, to find A inverse, we should calculate determinant of A first. Determinant of A. What is determinant of A? Determinant of A is 2 2 minus 3 2 3 2 minus 3 2. So, this determinant is equal to, I have to focus on the following. So, I have to look at this 2. So, in this process, I have to ignore the first row, first column. Therefore, 2 times 2 3 minus 3 2. Of course, we have seen, actually we are finding cofactor. You can expand this procedure with any column or row, it is up to you. You can do this expansion determinant in any way. I will explain you after finding this, after simplifying this one. So, next one you have to look at this one. This is 2 first row second position. You can say it minus 1 whole power first row second column. This is nothing but minus 1 whole power 3 is minus 1. Therefore, this is by default. You can write immediately. This is minus 2 times. So you should ignore those particular row and column. So the leftover matrix is minus 3, 3, 2, 2 plus of minus 3. The minus 3 is in the position of first row third column. Therefore, 1 plus 3 is 4. Therefore, minus 1 whole power 4 is 1. Therefore, I am not writing here. So, the matrix corresponds to that one is, so you drop this. So, that particular row and particular column you are left with minus 3, 2, 2, minus 3. You simplify this. This is 2 times the determinant is 4 minus of 3 into minus 3 minus 2 times, because whenever you are moving upward that is minus. So, minus 2 times minus 3 into 2 minus 2 into 3. This minus is because of this one. There is a minus sign over there that is appearing in front of minus 3. Minus 3 times. So, minus into minus 3 into minus 3 minus 2 into 2. So, that is 2 times 4 plus 9 minus 2 times minus 6 minus 3 times 9 minus 4, that is equal to 26. Minus into minus is plus, 24 minus 15, which is equal to 35. So, 35 is my determinant. Now, I have to find cofactor matrix of A. I hope you understand how to find the cofactor matrix of A. We have seen that C11 is equal to minus 1 whole power 1 plus 1 into determinant of the rest of the elements by ignoring the first row first column, and then C21 is equal to minus 1 whole power second row first column by ignoring those elements and then taking the rest of the elements in the determinant and so on. If that is the case, you are going to write your cofactor matrix is equal to minus 1 whole power 1 plus 1. You can directly write it. What are the elements after ignoring the first row and then first column? So, that means if you are in this position, you are finding cofactor matrix. The cofactor matrix is this one. So, 2, 3 minus 3, 2. 2, 3, 2, 3 minus 3, 2. Similarly, if you move to the second position, that is minus 1 whole power first row second column by ignoring the this position, and therefore corresponding you have minus 3, 3, 2, 2, minus 3, 2. The matrix determinant is minus 3, 3, 2, 2, minus 3, 3, 2, 2. Similarly, the third position is 1 plus 3. You are writing the rest of the elements that are left, that is minus 3, 2, and then 2 minus 3. This is the matrix. And similarly, you are writing minus 1 second row first column. By ignoring the second row first column, you have a submatrix 2 minus 3 minus 3, 2, and then minus 1 whole power second row second column is multiplied by multiplying with that minus 2, 2 minus 3, 2, 2, and similarly minus 1 whole power 2 plus 1, second row, sorry, third column, which is by ignoring 3 you have 2 2 minus 3. Similarly, the last one minus 1 whole power third row first column is by ignoring that you have a matrix 2 minus 3 and then 2 3 whose determinant is this one, and minus 1 whole power 3 plus 2, and by ignoring minus 3 in the third row you will be and the corresponding second column you will be getting 2 minus 3 minus 3 2, that is your matrix, and then last one is 3 third row third column, that is giving 2 2 and minus 3 2. After simplifying this you are getting a matrix. After simplifying this you are getting a matrix. Okay. Now you have to find adjoint of A, that is adjoint is transpose of cofactor matrix. That means you are going to write these rows into columns. This is transforming into C1, this is transforming into C2, this is transforming into C3. By doing that we will be getting adjoint of a matrix as. Adjoint of a matrix as how do you know the calculated A inverse is correct or not? To verify that we can multiply A with A inverse, that is A into A inverse, you should get the identity matrix. So implies your calculation is correct. So with this I am stopping the matrix theory second session today.